Today, we're going to journey about 5,000 light years away to a place of some serious cosmic extremes. It's this ghostly cloud of gas and dust that actually holds a pretty wild record. We're talking about the Boomerang Nebula.
So let me just ask you, what do you think is the coldest place in the entire universe? You might be picturing the icy surface of Pluto, or maybe some lonely rock floating in the darkness between galaxies. But the coldest spot we have ever found is something else entirely. It's not a planet, not a moon, not even what we think of as empty space. The answer is the Boomerang Nebula, and its temperature is it's almost impossible to wrap your head around it. It's 1 Kelvin. That's just 1 single degree above absolute zero, the point where all atomic motion just stops. To give you some perspective, that's minus 272 degrees Celsius or minus 458 Fahrenheit. It is just profoundly, unbelievably cold. Now, here's where it gets really weird. This seems to break a fundamental rule of the cosmos. See, the entire universe is bathed in this faint warmth left over from the Big Bang, what we call the cosmic microwave background. This radiation gives empty space a sort of baseline temperature, about 2.7 Kelvin. So how on earth can this nebula be colder than the background temperature of the very universe it's sitting in? To solve that little cosmic mystery, we first need to get properly introduced to this thing. So let's get to know this beautiful ghost in the cosmos. All right, so what are we even looking at? Well, the Boomerang is what astronomers call a pre-planetary nebula. It's about 5,000 light years from us in the constellation Centaurus. And what you're seeing is basically the death shroud of a star that was once a lot like our own sun. We're catching it in this really brief, really dramatic phase where the star is just violently throwing its outer layers out into space. When the Hubble Space Telescope got a good look at it, it saw this iconic bow tie or hourglass shape. This kind of eerie, symmetrical look is what first got astronomers' attention, and those curved lobes are what inspired the name Boomerang Nebula way back in the late 70s. But the shape is only part of the story. So how did we discover the one secret that makes this nebula truly bizarre?
Well, our understanding of this thing grew over a few decades. After it got its name in '79, the real breakthrough came in 1997. Astronomers pointed a radio telescope at it and found something shocking. The gas in the nebula was actually casting a shadow against the cosmic microwave background. It was absorbing that background radiation. And that was the smoking gun. For that to happen, the gas had to be colder than the radiation itself. A few years later, the amazing ALMA observatory confirmed the 1 Kelvin temperature and really helped us figure out the physics behind the chill. This really puts it all into perspective, right? On one side, you've got the CMB, the universe's base temperature, a chilly 2.7 Kelvin. And on the other, you've got this cloud of gas that is more than twice as cold. So, the big question is, how does it do it? How does it seem to defy the thermal rules of the cosmos? The answer is, it's not actually defying physics at all. It's just exploiting it in a really spectacular way. The nebula has become a vast, natural, cosmic refrigerator. The cooling trick here is a process called adiabatic expansion. Okay, that sounds complicated, but the idea is actually pretty simple. When a gas expands incredibly quickly, it has to use its own internal heat energy to power that expansion. So thermal energy, or heat, gets converted directly into kinetic energy, the energy of motion. The result, a massive drop in temperature. So here's how it plays out for the Boomerang. First, the star at the center blasts its gas out at a blistering 164 kilometers per second. For a star like this, that is about 10 times faster than normal. Then, as this superfast gas cloud explodes into the vacuum of space, it cools itself down, creating this huge region colder than anywhere else we know. If you've ever used a can of compressed air to clean your keyboard and felt the can get really cold, you've actually experienced this exact same principle. The rapid expansion of the gas inside literally chills the can. The Boomerang Nebula is just doing the same thing, but on a scale that spans trillions of kilometers. But that just brings up another question, right? A normal dying star just doesn't have enough oomph to shoot out so much material at such an insane speed. Something else had to be going on here. Exactly. We're talking about the star shedding almost 1.5 times the entire mass of our sun in just a few thousand years. To get that kind of momentum, you need a colossal amount of energy. So, where did it come from? And the answer is a pretty dramatic story of cosmic partnership and destruction. The dying star wasn't alone and had a smaller companion star.
As the main star puffed up into a red giant, it literally swallowed its smaller partner. This violent merger unleashed a huge amount of gravitational energy, which then acted like a turbocharger for the ejection of the giant's outer layers, flinging them into space at that record-breaking speed. As astronomer Raghavendra Sahai, one of the key researchers on this, put it, a binary interaction is really the only explanation that fits all the data. This kind of event not only provided the raw power, but also probably sculpted the nebula into that iconic bow tie shape we see. So there you have it, the whole picture. A dying star, a devoured companion, and a blast of gas expanding so fast it becomes the coldest known place in the universe. But this is way more than just a cosmic party trick. It's a fleeting, temporary wonder that's actually really important for science.
So why does this all matter? Well, the Boomerang Nebula is basically a perfect natural laboratory. It's a real-world test for our theories about how stars die, especially when they have partners. It shows us how all the heavy elements cooked up inside stars get recycled back out into the cosmos, providing the raw materials for the next generation of stars and planets. But this amazing state is temporary. In just a few thousand years, the central star will heat up and the nebula will warm up and just fade away. We are incredibly lucky to be seeing it during this brief, ultra-cold phase.
You know, the Boomerang Nebula was a complete surprise, a place that, by all rights, probably shouldn't even exist. It's just a stunning reminder that the universe is far stranger and more complex than we can even imagine. And it leaves you with a final thought. If something this extreme is hiding just 5,000 light years away, what other impossible wonders are still out there, just waiting for us to find them?